Today we're going to do an experiment with this. It's an instrument used to measure the velocity of wind called an anemometer. We're using the Raymarine tactic, which is designed for racing sailboats and is super accurate. Understanding the strength of wind is especially important for sailors, but on a moving object things can get really confusing. To illustrate, today we're going to conduct a series of experiments, starting first with the car. Here in the parking lot there's very little wind, but if we start moving, things change. All of a sudden the anemometer picks up the wind that's created by the motion of the car. This is called a headwind, and to confirm we can see that the wind speed measured by the anemometer is the same as the speed the car is moving. So that was an experiment with the car, but what does it have to do with sailing? Well, to figure it out, we've come here to the Coconut Grove Sailing Club in Miami to do an experiment to show you how headwind and ambient wind work together. Ambient wind is the wind that moves flags, turns boats on their moorings, and creates waves in the ocean. But the sails in the sailboat feel both the ambient wind and the headwind created by the boat's motion, just like a headwind we created in the car. If we draw each type of wind as a vector and add them together, the result is what is called apparent wind, or the total amount of wind that a sail feels. To measure this in real life, we're attaching our anemometer to the top of the mast of a small dinghy to see how apparent wind changes depending on how fast your boat sails. All right, we're out in the water here. We've got Brian Camelar as our test pilot. We've got the anemometer at the top of the rig, and we're gonna test and see what happens with the apparent wind when he's moving versus stationary. So right now he's stationary. We're reading about 12, 13 knots in the anemometer. Now Brian's gonna sheet in and go upwind. Start building his speed. We got 13 knots, 14 knots, 15 knots. So we're going from about 12 knots of apparent wind, 15 knots apparent wind. Now let's see what happens when he bears downwind. 10 knots, 9 knots, 8 knots. So you can see the apparent wind is changing based on the motion of the boat, just like what was happening in the car. Now let's repeat the experiment, but this time with a much faster sailboat, a hydrofoil kiteboard. Hydrofoils produce significantly less drag as compared to a conventional boat, allowing them to reach very high speeds. We're taking our anemometer and attaching it to the leading edge of the kite. This way it is not obstructed by anything and should give us an accurate reading of the apparent wind that the kite feels. The ambient wind is about the same as before, around 10 to 11 knots. We're attaching the anemometer's wireless display to the arm of pro kiteboarder John Modica so he can record his apparent wind while underway. Once the kite powers up, the foil on John's board generates an upward force called lift. It uses the same principle as an airplane wind. If you want to learn how hydrofoils work, check out the video here. While sailing upwind, John records an apparent wind of 22 to 23 knots, which is more than twice the ambient speed of the wind. So the next time you're on the water, whether on a small dinghy or a speedy hydrofoil, remember that apparent wind that your sails feel is a combination of ambient wind and headwind. To learn more, visit reach.ussailing.org. US Sailing's REACH initiative, STEM and environmental education through sailing.